Alright guys, so what we're going to be doing today in this lesson is solving exponentials and solving logs. So I'm going to start with exponentials. So the first type of exponential equations are the ones that you can get the same base. So my goal here is to get the same base. So 2 is a prime number. I can't do anything with 2 to the x. But I need to rewrite 16 with the same base. Well, 16 is equivalent to 2 to the 4th power. Now that the bases are the same, all I have to do is set the exponents equal to each other. So then x must be 4. Alright, so going to just this problem down here. 16 and 8, I want them to be the same base. So I'm going to get them to the prime base. So out of 16 and 8, the prime will be 2. So 16, like earlier, is 2 to the 4th, while 8 is 2 to the 3rd. Now for this example, I got to bring down the x minus 1 and bring down the x plus 3. Okay, so I got my bases to be the same. So I turned 16 to 2 to the 4th and 8 to 2 to the 3rd. Now I have two bases that are the same, so all I have to do is focus on the exponents. 4 times x minus 1 needs to equal 3 times x plus 3. Alright, distribute 4x minus 4, 3x plus 9. Combine my like terms, so I'm going to subtract 3x. That gives me x minus 4 equals 9. Add the 4 over, I get x equal 13. Alright, so there's my answer. Now, make sure you can always go back and plug them in and check and make sure they work out. Alright, this problem. I see that the base is already the same, so I don't need to do anything with the e. But the problem is this one here is a fraction. I need it to not be a fraction like the one on the left. So I got to think back to my properties. Properties say that if I have a negative exponent, I flip it. So I need to turn this positive exponent back to a negative exponent. So now I have the same base. So I set the exponents equal to each other and I solve. Subtract 2 over, I get negative 5. Divide by 3 and I just get negative 5/3. So there's my answer. So if you notice that there's a fraction, you're probably going to end up having to use a negative exponent. Okay, so going back up here, 4 and 64, I'm going to do prime. I'm going to change 4 to 2 squared, and then 64 is 2 to the, I believe, the 5th, and I'm going to just check real quick. Nope, not 2 to the 5th, so then 2 to the 6th, 2 to the 6th. Okay, so 64 is 2 to the 6th, and all I did was type it in the calculator and check to make sure. So 2 to the 6th is 64. Now I got to bring down what was already there. A 2x minus 1 needs to come down, and then the equal sign. Now that the bases are the same, I focus on the exponents. So 2 times 2x minus 1 needs to equal 6. So distribute. Combine like terms, finish it, I've got x equal 2. Alright, next one, 49. The prime there will be 7. 49 is 7 squared equals, I need this to also be 7 to some power. Because this was a fraction, I'm going to change it to a negative exponent. So it's going to now be a negative x exponent. Okay, so now set their same base, set the exponents. 2 equals negative x. Divide by negative 1, so x must be negative 2. Alright, next problem. Looking at this problem, I see something really different about it. I see square root. Now, in the last video, I reminded you that square roots can be written as exponents. So this is equivalent to 27 to the 1/2 power. Alright, now 9 and 27 are not the same base, so I got to think prime out of 9 and 27 is 3. So 9 is 3 squared, while 27 is 3 to the 3rd power. Bring down my exponents to x minus 1, bring down 1/2, bring down the equal sign. Now I'm ready to solve this. So I'm going to bring it up here because I need some space. I'm going to go ahead and distribute. That'll be 4x minus 2 equals 3/2. Alright, add the 2 over. So I get 4x equals, and let's see, that's 1.5, so that's 3.5. Divide that by 4, and my answer is going to be some decimal, so I'm just going to Figure out what that is. 3.5 divided by 4.875. So there's my answer. Alright, so with these problems, your goal is to get the bases to be the same. Okay, you always go to the prime. Go to the prime. Alright, for these problems you are not going to be able to get the bases to be the same. 7 is already prime. 60, there is no 7 to any power that's 60, because 7 squared is 49 and 7 to the third power is 343. I'm not going to be able to get the bases to be the same, but I'm going to use this property. I'm going to take the log of both sides. So log 7x equal log 60. Once I do that, what happens here is this x, because of this property right here, the exponent gets to go in front. So now I have x log 7 equals log 60. Now log 7 and log 60 are actual numbers, and I can find that using the calculator. So I'm going to type in log 7, and you can do this in any calculator. Log 7 is equivalent to 0.85. And then log 60, I'm just typing it into the calculator, is 1.78. So now to finish solving for x, I need to divide 1.78 by 0.85. And I get approximately 2.9. So for this problem, x equals 2.09, sorry, 2.09. Alright, now you don't have to only do log, you could do natural log. But you want to stick with those because those are on the calculator. You don't want to make it log base something. You just want to use log. So same idea for this one. I'm going to do log on both sides because 8 and 40, there's no common base for those that we can use. Okay, so I wrote my logs. So now what happens is this exponent now comes down and I can mess with it. So log 40 equals parentheses 2x minus 1 log 8. Alright, type in. I'm going to figure out what log 40 is. It's 1.6 equals parentheses 2x minus 1 times whatever log 8 is, which I'm typing it in, and log 8 is approximately 0.9. Now because this is multiplication, I'm going to go ahead and divide 0.9 over to the other side. So 1.6 divided by 0.9 is 1.77, so I'm just going to round it to 1.8. Equals 2x minus 1. And now I keep solving. I add 1 to 1.8, and I get 2.8 equals 2x. Divide by 2, and I get 1.4 equals x. Okay. Alright, the next set here, these are a little different because they have this minus 7 here. This one has a plus 11. Before I can take the log, I need to move this over. You cannot have anything on the outside. It has to be to the other side. So now I have e to the 2x plus 1 needs to equal 20. Alright, now I'm going to take the log of each side. Or you can do the natural log because it's e. It's up to you. It doesn't make a difference. So I'm just going to keep consistent and I'm just going to do log. So log e of 2x plus 1 equals log 20. Whoops. Sorry about that. Log 20. Alright, now the exponent comes down. So 2x plus 1. I'm going to use parentheses because that's all together. Log e needs to equal log 20. Alright, let's figure out what log e is. So log second e is 0.43. And then log 20 is 1.3. So now I'm going to take 1.3 and divide it by 0.43. And now my new problem is 2x plus 1 equals 3.03. So when I took 1.3 divided by 0.43, I got 3.03. Subtract 1 to the other side, I get 2.03. Divide by 2, 2.03 divided by 2, I get 1.2 practically. 1.02. Okay? Alright, this problem over here, same idea. I need to move this 11 first, so I'm going to move it to the other side. So now I've got 5 to the 3 minus x equals 24. I'm going to take the log of both sides. So log 5 of 3 minus x needs to equal log 24. As long as I do it to one side and the other side, I'm fine. Now I get to bring down the 3 minus x. And so I have to figure out what log 5 is and what log 24 is. Okay, so I'm going to take log 24. Log 24 is 1.38. Log 5 is 0.698, so I'll round that to 0.7. 3 minus x is 0.7. So now I take the 1.38, divide it by the 0.7. I get 1.97, so I've got 3 minus x equals 1.97. Now I got to subtract the 3 from that. Okay, so now I have negative x equals negative 1.03. And now to get rid of the negative, I just switch it. I switch the signs. So my answer is positive 1.03. Hopefully I'm not confusing you too much with these steps. The step that is new is taking the log of both sides. Once you take the log, you then move the exponents down. Alright, so I've got these last two, but I'm going to have to erase some things because I'm running out of room. So give me just a second to erase. Okay, so looking at this problem, I'm going to take I'm going to take the log of both sides. Log 4 of 1 minus x will equal log 3 of x plus 5. Now in this case, these are a little different. I'm going to have to move 2 exponents down. So this is going to become 1 minus x log 4 equals x plus 5 log 3. Alright, so let's see what log 4 is. Log 4 is 0.6. So this will be 1 minus x times 0.6. This will be x plus 5. And let's see what log 3 is. Log 3 is approximately 0.5. Now, because this one has a lot more problems, I'm going to go ahead and distribute these and then keep solving. So that'll be 0.6 minus 0.6x. Sorry. Erase that and make that look better for y'all. Equals 0.5x plus, let's see, half of 5 is 2.5. Alright, from there I would keep solving. Now I'm limited on the time on this video, so from there you just keep solving. Alright, so let me move to the next one just so you can have an idea of how to do these. There's nothing I need to move, but I'm going to have to take the log of both sides. So log 3 of x plus 1 needs to equal log 7 of 2x minus 5. This case, I'm going to have to move 2 sets of parentheses again. X plus 1 log 3 needs to equal another set of parentheses, 2x minus 5 log 7. So then from there, I would then figure out what log 3 is, figure out what log 7 is, distribute, and solve like you would solve any other problem.